problems and so forth. Okay, so chapter 8 continue, and now we're basically doing one-dimensional, two-dimensional, three-dimensional, and I will just put on the top here the next test is Monday, February 1st. I believe that you are on at 210. Yes, I will confirm that. That's a day. Hold on. Day 6. That is day 6, I believe. So no, then it's 12:45. Let's go with 12:30. Okay, 12:30. It's online, right? Unless it's 12:30 to 2 p.m. Unless I contact you, it's online. If you rather write it in person and I have room, you can email me that you're willing or wanting to write it in person, and then we'll see. I will have to first see the ones that I'm going to contact, and then everybody else, if you're still wanting to, let me know. February 1st, and the 3 units to focus on would be chapter 7, and that's quadratics. Chapter 8, which is what we're doing now. And the last one would be systems, so chapter 6. So we're doing those 3 chapters only, so you don't have to worry about trig, you don't have to worry about geometry. It's just these 3. And so in level of importance in terms of how much will be how much you can expect of each, right? This one is the first one. The first priority is chapter 7 quadratics. The second one is chapter 8, and then the third priority is chapter 6. So chapter 6 you won't have as much of, maybe just one word problem or something like that. But mostly chapter 7, which is quadratics. Yeah. Systems of linear, the one you just wrote. Oh. Yeah. You can maybe call it systems, right? This one is measurement and quadratics. Okay. So in terms of percentage, did I tell you the percentage already for that last test or no? Around 10. Okay, I said around 10. Akisha? Hold on. I told you 10%. I think that, yeah, we'll leave it at 10% then. Yeah. And then the 20% goes to the rest of the course. Okay. What's that? I'm just telling them about our test on Monday, February 1st. On the 1st, it's day 6. So day 6 last time. Oh, sorry. But if we can get like, I'm going to double, triple check. Day 6. So then it would be, today is also day 6. So it'd be the same 12:30 to 2. Right? Oh, what day is it? Day 6. February 1st will be day 6 as well. That's not this Monday, next Monday. Okay. Somebody say something here. So the test that you wrote yesterday, I'm going to mark that, and so sometime next week I'm going to give you an updated class report. And so you just need your student number to go check that. My computer is a little slow. Maybe I'll close. There were a bunch of things happening here. I didn't do attendance yet. No, I will. I remember you saying the have it valued at 10%, and the Anthony, yeah, so that's confirming. I didn't think so. No, I didn't do attendance. Are you going to give our tests back? Yes. So I'm going to do it marked so that when you come through here next week, you'll get it. And so basically the goal is between today and Monday, finishing chapter 8, making sure we understand that. And then we'll spend the rest of next week reviewing. So that's when you want to have that yellow review booklet on you. Okay. So it'll be, maybe 20 minutes or so where I kind of start off, guide you, remind you of things, and then the rest of the class you'll probably be working on your own. And the answer key will be, I have it all keyed up. I will probably reveal that later on next week, but I first want you to work through it before you peek at the answers. Okay? Unless, right, like if you're confused about something, take a picture, send me an email or something, and I can clarify things. I don't mind doing that. Okay. Okay, so chapter 8 continued. So we'll do some problems here, and then we'll end up with a chart towards the end. Okay. And I will do the attendance a little later. I just want to get going, make sure that I have this covered. Okay. Two similar parallelograms have the following areas. The original parallelogram has an area of 345 square feet. Another has an area of 125 square feet. A, determine scale factor used. B, if the base of the original is 4 feet, calculate the length of the base calculate the length of the base of the similar parallelogram. So here you have a scenario, right? First of all, highlighting the important, the key words here for you. Areas, so areas or surface area, anything like that, you know that the scale factor is a factor of k squared, right? Has been affected. Like the areas are going to be affected by a factor of k squared, right? So they tell you that the original, sometimes it'll plainly say original, other times you're just going to have to read and determine which one is the original, right? It has an area of 345 square feet, while the other has an area of 125 square feet. And notice that the word similar, right, is just, the word similar is just all shapes that have been affected by a scale factor are similar. Okay, that's just how it is, because all dimensions have been affected by the same scale factor. Okay, so determine the scale factor, right? They want k basically. Since areas are given, use, right, k squared is area of new over area of original. In this case, I like to use new and original instead of diagram actual. Okay. So substitute sub n, right? You get k squared is equal to area of the new is 125 square feet. Area of the original is 345 square feet. Same units, perfect. Okay, k squared is that. Therefore, k would be square root of 125 over 345. And if you recall, I gave you a formula where k is equal to square root of both areas, right? But it is very important that you know that the area of the new goes in the numerator and area of the original goes in the denominator. Okay? And if you're entering this all in one shot, I would strongly suggest you use brackets. Okay? So grab your calculators, make sure they're charged. Right, so I use second x2, right, 125 divided by 345, and you get 0.60, right? Oh, I forgot to show you, this is going to help you in grade 12 applied. It's not, I'm sure whoever teaches you grade 12 applied will show you this trick. If you want this as a fraction, this decimal here, the calculator does that for you. Watch. If you go math and pick the first one, fraction. So if this is your main screen here, right, you press math, the math button, and then you select the first option, fraction, right? So it'll take the answer that you just got above and turn it into a fraction. Sometimes it cannot do it. Wait a minute. Does it have to be the other way? Maybe it can't. Sometimes it cannot do it, and in that case, you're out of luck. Let me just try something. So let's say 0.75, for example. Math, fraction. I'm going to put 0.75 in here, and then go math fraction. Yeah, it does that. So it can't, in this case, it cannot do it, okay? But sometimes you will be able to. That's just an aside, not terribly important. But here's your scale factor. So k is 0.6, essentially, right? So you've brought it down to a one-dimensional factor, and this is what all the side lengths have been affected by. So the base, the height, and so forth. Okay, right, so B is asking if the base of the original is 3 feet, right? The base of the original is 3 feet. Calculate the length of the base of the similar parallelogram. So a base, right, is one-dimensional. Therefore, use K, right, base of new over base of original. So you always go back to this one. And in this case, we know what K is, so we can just plug it in. And then the base of the new, we'll find out base of the original is 4 feet. Okay, and so you basically just multiply these two, right? 4 times 4 feet times 0.6, and that's 2.4 feet. Parallelogram. I'm going to add a C here. I'm going to add a C because it's already set up. Why not? Right? So, right, if areas are related, you make sure the K has a power of 2. If linear, one-dimensional values are compared, you just use K, right? So that's important to distinguish there. C. If the volume of a prism that has the parallelogram as its base is 187 cubic feet. And we'll call this the original, comma, then what would be the volume of the new prism? So for you to understand what's happening here, I'm turning this into a 3D question, right? So imagine that you had the parallelogram as originally stated, and now I'm adding a height to it, turning it into a prism. Okay. Sorry, it's not the best box. Let me fix this. Some of you that are artists, you're probably laughing right now. That's okay. I know my weakness. Okay, so now this is a prism. Prism is just like if you have a base, you add a height to it. Now it's a three-dimensional shape, right? And the original has a volume of 187 cubic feet. Okay, and I don't know if you noticed already, this was a reduction, right? You can tell here because K is less than 1 that the new one has been a reduction, right? Let's see if this one looks better. There you go. Okay, this is the new, has a volume of what? Okay, we know it's a reduction because K is less than 1. Since the volumes are used here. Use K cubed is equal to volume of new over volume of original. We know already what the scale factor is. It's 0.6. We cube that. If this had been a fraction, I'd like you to use the fraction, okay? Is equal to volume of new, which is x, over volume of original, which is 187 cubic feet. Now you have a choice. You can cube this first and then cross multiply. And I think that's what I'm going to do. So go 0.6 to the power of 3. That's 0.216 is equal to x over 187 cubic feet. Okay, and now if you want to, you can put the 1 under here, right? So it's cross multiply and divide. So the volume of the new one, that's what x stands for, is 187 cubic feet times 0.216. Cubing this. Yeah. And that is 40.39 cubic feet. See, if you just went 187 times 0.6 and you forgot to cube it, that would be completely off because the volume is actually affected 3 times, right, by the scale factor. Because you got to think there are 3 dimensions that are affected: the length, the width, and the height, right? All 3 dimensions. That's why you have to cube the scale factor when you're working with the volume. I think I'm going to leave it at that. Now we're going to do a table. Two lengths. All right. When you're writing notes at home, right? Am I going too fast still, or is it?
I think you're going a bit too fast because then I have to listen and
Okay.
But
what about everybody else? Danielle? Oh, it's fine. Jadley? A bit too fast? You don't know? I'm not taking notes. I'm just kidding. Laura, you were saying it's okay? Keisha, Maxwell? Keisha? Sometimes a bit too fast? Sometimes a bit too fast? So it's, but when you're in here, you're fine?
kind of. Yeah, just do on. No, I'm not. I say go 0.25 times slower, like a YouTube video.
Okay.
Yeah.
So I should pre-record my lessons and then you decide, right, how fast that would be. Okay. Backside. I'll try to keep that in mind. Okay, so I'm going to grab my ruler here. I'm going to make a table, but first I'm going to tell you what's going to be on that table, okay? Complete the following table. So we're going to figure it out. So the first column I'm going to use this here is object. We're going to have length in inches, we're going to have our width also in inches. We're going to have our scale factor, which doesn't have units. Area in square inches. And that's it for now, I think. Yeah, just those. Later on, we'll do one with volume yet on the side here.
Yeah, then we need the height.
Nope, you don't.
Really?
That's the beauty of this. So object number 1, we've got 4 inches, 3 inches, K is 1, area is 12. Object 2, we're going to figure that out. Scale factor is given. That is it. For the third one, let's leave a blank line there. Right, so we're going to basically make the first one like that. And then the second one, because we're going to have to fill in portions of it, we're going to leave 2 lines like that. Three. So we're going to leave 2 lines every time to have a bit more space. So object number 4 and object number 5. And we'll fill in the pieces that only some of them are provided. And what I'm going to do is highlight the ones that were given, okay? That way later when you look back, you know which one you filled in. And I will see you on a table like this next week, probably Monday or Tuesday. So review this. You'll also get a chance to practice. I have worksheets for you on this as well. And basically, when you're given a table like this, I put the original at the top. But in a sense, the original is going to be given to you, and then there's going to be a whole bunch of copies made. Right? So 2, 3, 4, and 5 are all copies of the original here. So you need to identify the original. And there's 2 ways to do that. The one that has everything filled in, or you just look for k is equal to 1, because that's right, the original is going to have a scale factor of 1, okay, because nothing changes there. And so we're going to do one at a time. We're going to fill in. So I'm going to give you some time at home to make this table. And in the meantime, I'll just do the attendance. And if you could get your keyboards ready. Okay, Gian, are you there? Hi, Gian. Charles? Here. All right, Cedric? Kyle? Let me just pause the video. That doesn't need to be on there. Okay, let's fill this in. Have your calculators ready, okay? When you are given the scale factor, okay, that's the easiest one to do, right? So basically, I will put a note down here. Scale factor provided, right? Then you should think of, right, K is gonna be, no, never mind, sorry. My bad. You should think of new is equal to K times original, okay? That is going to be, so to find basically these new, the dimensions of, because this is like the new number one, this is the new copy, the second copy, so these are all new shapes that are being created, right, based on the original. And so if you're given the scale factor, use this idea to get you your new dimensions that you're supposed to find. So length and width, they're both one-dimensional. So to fill in this box, you would just go, right, K times original. So since K for this particular shape is 4, so you'd go 4 times the original, right, and you get 16 inches. So obviously this is an enlargement, right, increase, because K is bigger than 1. So I'm going K times the measurement of the original. So it's 4 times 4 inches. This one would be 4 times 3 inches, which is 12 inches. This one you have to be careful. It's area. So instead of K times original, sure, but don't go there because you're going to get in trouble down the road, okay? It is length times width in this case because it's a rectangle, but you won't always be given both dimensions. I just want you to see it, okay? See the relationship. You're going to have to go K squared times the area of the original, right? So that's 16 times 12. And that is 192 square inches. So this is the area of that enlarged shape that has been increased by a factor of 4 when it comes to the dimensions, right? But you do see that 16 times 12, right? It ends up happening again, 16 times 12. So yes, Mark was saying just go length times width to get that, but I could actually not give you the width, in which case you're bound to use this idea that you have to square the scale factor times the area of the original. Does that make sense? Okay. Next, the third So we always go back to the original, folks. What is my scale factor? You first need to find a scale factor before you can fill in the rest. Okay, so how do we get our scale factor? If you need to find the scale factor, right, we have to either use k is equal to new over original. Okay, k is equal to square root of area of new divided by area of original, or k is equal to cube root. We don't have volume right now, but it would be volume of new over volume of original. So we have to use one of these three to come up with our scale factor. Okay, and the key idea is here to find scale factor. Look at, right, what is it that you're given? You're given the length of this new shape. So you can use both lengths to come up with that scale factor. So you're going to use this one. Okay, so k would just be new divided by original, and that is 1.5 or 3 over 2. Okay, so that's your first order of business. Once you have that, it's the same as before. Here you will go k, I'll put that in brackets, times the length of the original, right, which is 4.5 inches. Then here it would be k squared, why? Because we're talking areas, right, times the area of the original, which is 12. And so let's go 1.5 squared times 12. That would be 27 squared inches. That would be the area of that resulting shape. Okay, of the copy of that original. So you always go back to original. Don't go just the one above it. Okay, always back to the original. And then on the fourth shape here, right, you still need your scale factor, right? If you need to scale factor, use one of these three. In this case, the only thing that's given to you here is the area. So you have to compare the areas to come up with the scale factor. So because we're using areas, we have to use this formula for k. So k is going to be square root of area of the new, which is 120, divided by area of the original. Okay, and in this case, this you should be able to do in your head, right? This is going to be 100. Square root of 100 is 10. So the scale factor there is 10. No, sorry. Guys, it's Friday, right? 120 divided by 12 is 10. You got to take the square root of 10 to get that. My bad. That's 3.16. If you want to use 4 decimals, very welcome to do so. Okay. In fact, I will probably do that here. Like that. If it doesn't stop, use 4 decimals, especially on a table like this. Use 4. So now that you have the scale factor, right, you can use it to fill in the rest. And these are all one-dimensional here. So we will go 3.1623 times the length of the original. Here we'd go 3.1623 times the width of the original. Okay. And Let's figure this out. This is 12.65 inches. And this is 9.49 inches. Okay, so there you have the length and the width that would result in this. Okay. Last one. They're giving you the scale factor as a percent. Turn that into a decimal, right? Now you have the scale factor. Now it's basically the same as up here. Let's start with this. It'd be 0.25 times 4 inches, which is 1 inch. Maybe 0.25 times 3 inches. Going back to the original, right? And that'd be 0.75 inches. And then here, watch out for this. You're comparing areas, so you have to square it and then multiply it by the area of the original, which is 12 square inches, right? And that gives you 0.75 square inches, which can be, right, validated. If you multiply these two, right, of the sides of the rectangle, you get that area, which makes sense. Can I just add here, if scale factor is provided, let's complete this with all three variants of this. Area of new would be k squared times area of original. Volume of new would be k cubed times volume of original. And then you have, right, all three variants if the scale factor is provided, because then you just plug that in. If you want to know the scale factor, you first have to use one of these and then go from there. For this, I have two worksheets that you should have received in the package that you picked up whenever that was. Was it before break? I think so. And I will show you what they look like. If not, I'll post them as a PDF as well. Don't think I have any more printed copies, unfortunately. So how about this? I first need to make sure you write this down. So everybody at home, write it down. What should I say about charts that you see like these? First of all, that the original may not always be the first one, the first row. It may be anywhere in between, so you just have to find it. And then you have to work up or down from it, but always remember, it always goes back to the original, right? So once you know your scale factor, right, you always multiply it by the original, multiply it by the original. Here we first have to find it, so we use both areas to find the scale factor, right? So there's one with a bunch of spheres, and there's one with a bunch of cones that I've made. Okay, so I'm going to show you the first one. This is the first one that I want you to try. So go look this one up. Okay, and the other one looks like this. There's a bunch of spheres there. So I'm going to kind of leave them both there. So that is your task to do right now. And how about, I think time-wise, you might only have time for the cone, maybe the spheres.